All right, so this is part 2 where I'm just going to focus on our polyatomic ions. They're going to follow the same guidelines as I went over for the molecules that follow the octet rule. The only difference here is that if we have an ion that has a positive charge, indicating that it has lost electrons, we're going to take away our total from our total valence electrons that we're going to add up. And then in the opposite manner, if we have a negative charged ion, I'm going to be adding in electrons to account for the charge. So here we're going to look at the phosphate ion. So if I add up my phosphate, I have 5, plus I have 4 oxygens that each have 6 electrons, and then I have a -3 charge, so I'm going to be adding in 3 additional electrons. So in this case, I have 24 and 8, so I'm going to have 32. Okay, I'm going to start with phosphorus in the center. I'm going to put my oxygens around it. Okay, I'm going to start with single bonds here. Okay, so that's 2, 4, 6, 8. So that means I get to 24. And if I look, I need 6 on each oxygen. So this would be 6, 12, 18, 24. So I'm going to go ahead and place these here. Now, one little thing, because we have not talked about resonance structures, is we don't actually find that phosphates exist in this manner. But for what we know right now, we're going to use this as our structure. So this will be 24, 0. So phosphorus has a complete octet based on the structure, and then my oxygens. One little thing with this, though, is that because this is a polyatomic ion, I'm going to be putting brackets around it. Okay, and then I'm going to indicate the charge on the outside of the brackets, just kind of like how we did our Lewis dot diagrams for a single ion with the brackets and the charge on the outside. Just keeping in mind that with our polyatomic ions, they actually have these covalent bonds on the inside, and then they can form an ionic bond with another ion. So let's look at ammonium here. Nitrogen has 5 valence electrons. I have 4 hydrogens. They have 1 each. And now I have a +1 charge here. So I'm going to take away an electron. So in this case, I only have 8 electrons to work with. I'm going to start with nitrogen in the center. I'm going to place my hydrogens on the outside. Like that. And that gives me my 2, 4, 6, 8. So -8 equals 0. Okay, which makes sense. Nitrogen has the 4 around it, and we have hydrogens each with their 2. We'll also talk about this one later on as well, where this has formed a coordinate covalent bond, so we'll get into that in a later lesson. And then just like our other polyatomic ion, I'm going to put it into brackets and then place that +1 charge on the outside. All right, let's do one more of these polyatomic ions. Here we have the cyanide ion. Carbon is 4 valence electrons, nitrogen is 5, and then that -1 charge there, I'm going to add in an electron to get myself to 10. So I'm going to start with my carbon and my nitrogen, start with 1 bond between them. That's 2, which means I have 8. So I'm going to plug 4 on each side, get myself to 0. Red flag should be coming off in your mind in the sense of, oh, these guys don't have 8. So just like the dinitrogen molecule that we did before, we're going to start moving electrons. So I'm going to move the first 2 to the center. Okay, that gets nitrogen up to date. Carbon's still at 6 though, so I'm going to take 2 more. And move that to the center there. Okay, and just like the other ions, put that in brackets, okay, and put that charge on the outside. Okay, so I still have my 10 total valence electrons there.